Hello, and welcome to Interpreting Graphs. I think you'll find this lesson, I find it fun, and I think in the past students have found it fun, so I think you'll find it fun. So we're going to learn to interpret information given a graph and to make a graph to model a situation. So our vocabulary, a little shake there, we have continuous graphs and there are discrete graphs, and you need to write the definitions of these. So a continuous graph is a graph made up of connected lines or curves. And you'll see, I'll show you some, actually the very first one, I'll show you how that's a continuous graph in just a minute, how the lines and curves are connected. Discrete graph is a graph made up of distinct or unconnected points. And on this, I will, the very last graph we'll look at will be discrete, and I'll point that out to you when we get to it. And you'll see a situation. I think it'll make more sense to you when you see it. So our first graph is continuous, and if you look here, we've got, we could say there's a point here at 50, 0, and then there's one here at 50, whatever that coordinate is, and here, and here, and here, and we connect the dots. Well, as time goes on, time never stops. So as it goes on, there's always going to be a speed of the car involved, even if it's 0, as time goes on. And so like over here, on the second graph, graph 2, that's a speed of 0, but time ticks on. So that's called a continuous graph because for every point, there's a corresponding y-coordinate. Okay, so in this particular one, situation, you have to pick which graph goes with this situation. It says Mr. Lee is traveling on a highway. He pulls over, stops, then accelerates rapidly as he gets back on the highway. So if we look at these, we're picking either graph 1 or graph 2. The answer is graph 2. Now, you may say, well, I don't get that. And so I'm going to go through this one with you, and then we'll see if you can figure out the next one. These aren't perfect because I see some flaws, and you might see some flaws too. So you might want to pause the graph and just look at it and see why it's graph 2 instead of graph 1, and then come back and I'll do my explanation. So it says Mr. Lee is traveling on a highway. All right, now here, if he's traveling on the highway, right now he's going 55. But notice, as time ticks away, his speed is getting slower and slower and slower. Now, it never says that. It also, here, he's traveling at a constant rate of 50 miles per hour. So he's either got his cruise control on or he's just able to have a good steady foot. Then, it says he pulls over, stops, and then accelerates rapidly. Well, if he pulls over, that means in order to pull over, he could be going 60 and he's thinking, okay, I got to pull over, so I'm slowing down, I'm slowing down, I'm slowing down. And then all of a sudden I start slowing down at a slower rate. But when I get down here, I've stopped. And now I'm stopped. So he could have pulled over and he stopped on the side of the road. Then he's going to get in his car and he's going to accelerate rapidly. So over this short period of time, he goes right back up to 55 degrees. In this span of time, the span of time is longer than this span of time, so he slows down at a slower rate than he's speeding up right there. So it is graph 2. Now, there's an example, the next example, let's look at, and then we'll go through graph 1. So the next graph says Miss Montoni slows down as she leaves the main road. She continues to slow down as she turns onto other streets and eventually stops in front of her house. Well, we know it can't be this one because we just picked it. So if we look at this one, I see some flaws in this one, but I understand they're just skipping some things that they're saying. So here she's traveling at a constant rate of speed. She's probably got her cruise control on. And then she starts to slow down. Here's that slow down right there. And it says as she leaves the main road. Well, right here, for some reason, she slows down and then she goes for a constant rate of speed of 30. They never say anything about that. So what I'm thinking is maybe she slows down and she's pulling over into a slower lane. But then if she's going a constant rate of speed of 30, I'm thinking maybe the speed limit really is about 30, and she was just speeding here. Maybe she saw a cop, she slowed down, then she's going, cruising at 30 miles per hour. And then it says she continues to slow down and eventually stops in front of her house. So now she starts to slow down again, and she lives on this 30-mile-per-hour street, and she comes to a complete stop on that street, and that's her house. This point is not her house. This is the point where, in this particular point in time, her speed is 0. So it's graph 1, but I think they left out a lot of information. And you're going to have to tell a story with one of them, and I would expect you to be a little bit more detailed than in your homework. You will be a little more detailed than that. Okay, so let's look at another set of graphs. So we've got graph 1, 2, and 3, and it says tell which graph corresponds to the situation described. Jamie begins the race soon feels a pain in his muscle. He is unable to complete the race. So that would be graph, and if you want to stop and look at it yourself and see if you can figure it out and then turn it back on and see if you're right, go ahead and pause it now. The answer is graph 2, okay? Right here, Jamie, he's going at a pretty fast speed, but he starts to slow down gradually. Then he starts to really slow down, and I think there it's because, something's going on with his, he feels pain in his muscle. So he's probably already kind of feeling it, but it's not so bad, but he does slow down. Now he's really slowing down quickly. And then he stops the race because there's no speed and time keeps ticking on. So it's graph 2. All right, we're going to look at the same 3 graphs, and this time Melissa builds up her speed during the beginning of the race. She maintains her speed for the remainder of the race. So if you want to pause here and see if you can figure out which one that is, it's not going to be 2, but either 1 or 3. And then turn it back on, and I'm going to tell you the answer right now. So the answer is graph 1. And in that situation, okay, her speed is right here, whatever speed that is, but then she starts to gradually go a little faster, and then she maintains this constant speed throughout the race. Okay, now you might want to make up a story for this one. You can tell me tomorrow what your story is. I've got some ideas too, but you can run it past me tomorrow. So if you want to write down, you can pause and do that, and then come on back. You don't have to, but that's just an option. All right, so it says create a graph for the situation. Tell whether the graph is continuous or discrete. Now you've got this graph on a slide. So it says the table shows the temperature inside a car over time. So I would like for you to pause the video and actually try this, plot the points, and think about the time and what time does, and if you think it's continuous or discrete, and then come back and you can look at the answer. All right, so if we plot the points and connect the dots, it's going to look like this. And the reason we connect the dots is because from 8 to 8:30, there was 801, 802, 802 and 20 seconds, 30, it's continuous. So we're going to have a line there because the temperature didn't change here as far as we know. And then from 8:30 to noon, it steadily rises to 82. And then from 12 to 12:30, it starts to go back down. And if it's inside a car, if the car is just sitting in a parking lot, maybe the sun went back in, so it started to decrease in temperature, that kind of thing. But it would be continuous. Now the second one, again, you're going to create a graph and tell whether this one's continuous or discrete. And you've got a market that sells pumpkins for $5 each. So pause the video and see if you can figure out what you would do there, and think about the horizontal axis being they're selling pumpkins and they're $5 each. So what would you put down here if you're buying pumpkins? The amount of pumpkins that you can buy. So pause the video and try that. All right, so if you've come back now, you could sell 1 pumpkin, 2 pumpkins, 4 pumpkins, 6 pumpkins, 8. You could also sell 1 here, 2, 3, 4, 5, and so on. So if they're $5 each, if you don't buy any, that's going to be 0. If you buy 1, it's $5, 2, 10, 3, 15, and so on. This is a discrete graph because you're not going to buy a half a pumpkin or 1.5 pumpkins or 1 3/4 pumpkins. You're going to buy whole pumpkins. So each whole pumpkin would designate a particular cost. So that's discrete. There are just points. You do not connect the dots. And that's the end. And tomorrow you'll come in and we'll do some more interpreting graphs. And if you want to figure out a story for graph 3 here on example 1D, I encourage you to do that. Have a good evening.